Hi everyone, welcome to Ms. Sawagid's math class. We already learned about absolute value. We learned the absolute value of a number is its distance from the zero on a number line. For example, the absolute value of x equal 2. Bring your number line. Which numbers have the distance away from the zero equal 2? Positive 2 is 2 away from the zero, and negative 2 is 2 spaces away from the zero. We also learned solving absolute value algebraically, following those easy steps. Step number 1 is to isolate the absolute value on one side of the equation using inverse operation. Step number 2 is to write the two linear equations and solve for that variable. Why do we write two linear equations? Because one answer should be positive and the other answer should be negative because they make the same distance away from the zero. Lastly, check your solution to make sure it's right. So for today's lesson, we're going to build on what we learned. Solving absolute value inequalities, let's start by graphing. For example, the absolute value of x, this time more than 2. That means I need all possible solutions, all possible numbers, more than 2, and all possible numbers less than negative 2. Because they both make the same distance away from the zero. So bring your number line and let's graph x more than 2. So since 2 is not a solution, use an open circle, and I need all possible numbers more than 2. So go to the right, and then also use open circle. I need all possible numbers less than negative 2. So bring your arrow to the left. Does that remind you of the compound inequality joined by the word or? And think about it. Unlike 3, 4, 5, they have the same distance from the zero as negative 3, negative 4, negative 5, and so on. What about the absolute value of x less than 2? I need everything that is less than 2. So bring your number line and graph all possible solution that is less than 2. Since 2 is not a solution, open circle, less than 2, that means I need to go to the left, from 2 to the left. But doesn't the negative 2 also have the same distance to the zero? So I need all possible solutions with x more than negative 2, open circle because negative 2 is not a solution, but everything going to the right would be a solution. Does that remind you with the compound inequality joined by the word and? Goes from 2 to negative 2 are possible solutions, but the 2 and the negative 2 are not a solution. So solving absolute value inequality, an absolute value inequality is an inequality that contains an absolute value expression. For example, the absolute value of x less than 2 and the absolute value of x more than 2 are examples of absolute value inequalities. But keep in mind, the absolute value of x equal to means the distance exactly 2 away from the zero, from both sides, positive or negative on a number line. When we talk about inequality, it's all possible solutions with the distance away from the zero. So can the distance away from the zero be a negative number? Absolutely not. No. So by definition, the absolute value of an expression has to be greater than 0. And we will be using this a lot in the lesson. So now to solve absolute value inequalities when it's more than or less than. The absolute value of ax plus b more than c, you use those two compound inequality that's joined with or. Ax plus b less than negative c, or ax plus b more than c. When the symbol is less than, to solve ax plus b absolute value less than c, then you use those two compound inequality that's joined by the word and. Ax plus b more than negative c, and ax plus b less than c, or you can find one inequality, ax plus b more than or equal to negative c, less than or equal to c. In the inequalities above, you can replace less than with less than and equal, and more than with more than and equal. Now I will discuss the 4 easy steps to solve absolute inequalities. Step number 1 is to isolate the absolute value using inverse operations of inequality, which we already know all 4 of them. Step number 2 is to write the compound inequality with the 2 rules when it's less than or equal, or when it's more than and equal. Those are the 2 compound inequalities. And then step number 3 is to solve for the variable that is in the inequality. Step number 4 is to write your solution and graph it if possible. Why do we say if possible? Because sometimes you will have no solution and you can't graph it, or real numbers and you can graph that, or when you have a joint or compound inequality. Now, let's solve and graph the inequality. I will leave the 4 easy steps for you to follow. X plus 7 absolute value plus 1 less than or equal to 2. Step number 1 is to isolate the absolute value. Is it on one side of the inequality? No, it has the 1 on the same side as the absolute value, so get rid of that first. Use inverse operations, so it's the subtraction property of inequality. Subtract 1 from both sides. You end up with the absolute value of x plus 7 less than or equal to 1. Step number 2 is to write the 2 compound inequality. Since it's less than or equal, then we will be joining those 2 inequalities with the word and. X plus 7 more than or equal to -1, and x plus 7 less than or equal to 1. Now let's solve for the variable x. Let's start with the one on the left. Since I'm adding 7, subtract 7 from both sides, you end up with x more than or equal to -8. Subtract 7 from both sides, you end up with x less than or equal to -6. So the solution is, now since it's and, we can write them as one compound inequality, but make sure to start with the least number first. -8 is less than or equal to x, write it down, and x less than or equal to -6. To graph it, this is the graph. Use closed circle on -6 and -8 because it starts from -8 to -6 only. That's the graph of compound inequality joined with the word and. Now let's practice solving graph the inequalities if possible. You have 3 examples. Let's start with the far right. The absolute value of 8x minus 11 less than 0. By definition, the absolute value of an expression has to be greater than 0. That means whatever that expression is, the absolute value of 8x minus 11 is in the negative because it's less than 0. So -1, -2, -3, all these numbers to -infinity. Can the distance be negative? No. So the expression cannot be less than 0. Therefore, no solution. So right away, I can't do anything. Can I graph? No solution. No. Now let's start with the second one in the middle. The absolute value of k minus 3 less than -1. Again, all these numbers or that expression will be in the negative. By definition, the absolute value of an expression has to be greater than 0. And this is not greater than 0. That's less than -1. Therefore, no solution. And I also cannot graph it. Now the last one. The absolute value of 10 minus m more than or equal to -2. Yes, there's a negative, but by definition, the absolute value of an expression has to be greater than 0. I know what you're thinking. -2 is a negative number. But so does 1, 2, 3, all possible numbers more than -2. So that's not the same as less than -1 because you're thinking about all the numbers less than -1. In this case, you're thinking about all the numbers more than -2, which leads you to the positive solutions. By definition, the absolute value of an expression has to be greater than 0. And yes, there will be some numbers greater than 0. So all real numbers are a solution. Bring your graph. I can graph this and put all real numbers. So why did we put all real numbers? If you think about -2, here's -2 on a number line. Same as -3, -4, -5 to -infinity, has the same distance to 0 as +1, +2, +3 to +infinity. Therefore, all real numbers are solution to this inequality. Before we solve real life problem, I wanted you to think about this marker. This marker costs you $5. You're willing to pay $2 more or less. So how much would this marker cost you? There's a range of $3 to $7 because it's $2 less and $2 more. That will help you understand this real world problem. You are buying a new computer. The table shows the prices of computers in a store advertisement. You are willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your condition? And you will know that from the table. Look for your clues to write the inequality. Clue number 1, what are you trying to find? And what I'm trying to find is the number of computers that meet the condition. At most $100 means maximum, so use less than or equal in your inequality. Clue number 3, willing to pay the mean price. So I need to find the mean of all these computers. And remember, the mean is the same as the average. So to start, mean equals the sum of the computer prices divided by the number of the computers you have. Look at your table, add all these numbers up, and you will get 6,640 divided by the number of computers, which is 10. And that gives you $664, which means the mean price for the computer is $664. Now think about the absolute deviation. When we said absolute deviation, remember when we talked about the marker, we said we are willing to pay $2 more or less. In this case, you are willing to pay $100 more or less. And how do you find that? It's the price of the computer minus the giving value. So to write the equation, X is what you're willing to pay, minus 664, which is the mean of these, or the average of all these prices of the computer, less than or equal to 100. So step number 1 is to isolate the absolute value, and it's already isolated. Step number 2 is to write the inequality. This time, because it's less than, that means I need to join them with the word and or write it as one inequality. X minus 664 in the middle, more than or equal to negative 100, or less than or equal to positive 100. Now solve by the addition property of inequality. Add 664 to all three sides of the inequality, left, middle, and right. You end up with 564. Bring less than or equal to X, less than or equal to 764. So what that means, the price of a computer you can buy is between 564 to 764. Now look at the table and see how many of those prices are you willing to buy. You only have 6 computers you can buy from the table. Since this is your last lesson for this unit, I will go over one more word problem, but it doesn't have to be an absolute value. I want to see if you're able to write the equation. You start a small baking business and you wanted to earn a profit of at least $250 in the first month. The expenses in the first month are $155. What are the possible revenues that you need to earn to meet the profit goal? First of all, what are your clues? Clue number 1, what are you trying to find? We're trying to find the revenue, so give it the letter R because we don't know what it is. We need to find it. Clue number 2, at least means minimum, so use more than or equal to in your equation or inequality. Clue number 3, 155 is an expense. So what do I do with that? It needs to be taken away from the revenue and still make a profit of $250. So write your equation. R is the revenue minus the expense, which is 155. Use the symbol more than or equal to 250 because I need more than 250 as profit. Add 155 to both sides of the equation to isolate R. You end up with R more than or equal to 455. So in the first month, you have to make 455 and more to meet the profit goal of at least $250. That's it for today's lesson. You guys have a great day. Thanks for listening.